Hello friends, I am Mr. G. Pujari, working as assistant professor in Sharath Institute of Technology, College of Engineering. Friends, I am having my channel Creative. So in this channel Creative, I am friends uploading the videos related with technical content like engineering, technology, and friend also I am uploading the videos related with non-technical like general knowledge purpose. So initially friends, I am appealing you subscribe my channel so that you will not miss any kind of new videos whatever I am uploading on this my creative channel. So friends, in last lecture we have started this chapter drawing of assembly and detail. So till this lecture just I am going to give you some kind of review whatever we have learned, so that if you want to learn you can be watch my videos whatever have I have uploaded whatever previously. So friends, in drawing of assembly and details we have seen earlier about the introduction. So whatever the introduction may be according to point of view industry and according to point of your subject point of view for your academic. So why it is important we have seen. Then friends, we have also discussed about the detail drawing. So what is mean by detail drawing, why it is important, then what kind of things we require to add into good detail drawing contents we have seen. So friends, also we have seen about the assembly drawing, why how we are preparing the assembly drawing from detail drawing, that also we have discussed, and whatever the good things we require to add in a whatever the when we are saying when one good assembly drawing, so how many things we require to add in that also we have seen. Then also friends, we have discussed about the types of assembly drawing. So because there are so many types of assembly drawings, so we require to consider how many things like design assembly drawing, layout assembly drawing, then installation assembly drawing. Then also we have discussed about the working assembly drawing, general assembly drawing. Then the requirement of assembly drawing we have seen. So required views, sectioning, dotted lines, dimension, bill of material means what. Then also we have discussed about the scale, method of projection, shop process, name of components, material of part, and design checked by means what, why it's required to add. So these things we have discussed in previous lecture. And friends, also we have discussed about the when we are going to draw a assembly drawing from detailed drawing, so how many things we require to consider. So friends, these all the things we have discussed in our earlier lecture. If you want to learn all these things again, you are having chance that I have uploaded all the data on my previous lecture on my creative channel. So anytime you can watch my previous lecture and you can get the knowledge about the whatever the previous topic we have discussed. So friends, just I want to discuss about this point whatever we have discussed in our earlier lecture, because this is having connection with our next point. So friends, so steps to draw assembly drawing from detail drawing. So this we have already seen in our last lecture. So how we are going to draw, just I am going to give you within a few seconds how many things we have discussed and why it is important. So when we are going to draw a assembly drawing from detail drawing, how many things we require to consider. So here whatever the part list we have given here, on the basis of that in a part list, first of all we require to check how many number of components are given. On the basis of that we can locate, because in a when we are going to draw a assembly drawing, that time friends, here we require to see first of all the how many things are shown on a detailed drawing. Okay, then see the detail drawing we require to learn thoroughly, internally and externally, so that we will get the know about the dimension of this whatever the detailed drawing. there may be a number of components like 4, 5 number of components may be there in a detailed drawing. So once you have understand how many number of components are there and what is the overall dimension of this component, so then we are going to match with each other in a detailed drawing. So which component is going to fit with each other, and after this we require to imagine if these components are going to assemble, how they are going to perform. Okay, once you have imagined, then you will realize this which component required to add here again subsequently, so that whatever remaining parts we are going to add in this. So like this, first of all we require to imagine which parts required to add at which location by observing the dimension, because sometimes there is a given some kind of holes, some kind of stud is there. So whether if dimensions are matching this hole and stud, then definitely this stud is going to insert into this hole. So like this we require to make some kind of permutation, we require to trial and error. By observing this we are going to do a assembly drawing. So after this number of trials we require to take some front view, top view and side view. Okay, first of all we are going to draw a front view, and whatever we have drawn in a front view, that we are going to project into your subsequent views of your top view and side view. Okay, so like this friends, these things we have learned earlier in our previous lecture. So just I have given you brief about how we have learned in the last lecture about how we are drawing assembly drawing. So friends, today we are going to see about the steps to draw a part or detailed drawing from assembly drawing. Okay, so whatever friends we are having the assembly drawing, on this assembly drawing how we are going to make a detailed drawing, that is the main point in today's lecture. So friends, first understand the assembly drawing thoroughly by referring the part list and the different orthographic views of the unit. So friends, in your problem or in your question they have provided you a assembly drawing. So assembly drawing, there may be having some views like front view, top view and side view. Okay, so first of all observe this front view, top view and side view. Then check your part list. In friends part list, how many things are there mentioned? First one is a serial number. Second list, in this list there is a content of or title of this name of the component. Then third column is your component material, which type of material is there for your component. And fourth one is how many number of type this component is used. So friend, in a serial number they have given the numbers 1, 2, 3, 4, 5. So like this, in assembly drawing also given numbers to your that component. So the component number may be a 1, 2, 3, 4, 5, 6, 7, 8. So like this, just check number 1 and then check in your part list what is the name of that component, what is the material of that component, and how many times this component is used. Whether this component is used in only single time or whether this component is used in 2 times. If component is used in 1 time, then check the location where it is used. If this component is used in 2 times, then friend check how many times this component is used and where that is the location is where. So like this friends, whatever the number of components may be a 4, 5, every component we require to check what is the name of that component and how many number of times that component is actually used in our drawing. So here friend, we have located our component is a first step to understand that. Then study the functional aspect of the unit as whole. This will enable to understand the arrangement of the parts. Okay friends, then we have to understand functional aspect of the unit. So whatever the assembly, if suppose we are going to move each part, then when if one part is moving, how other part can be moved, that is we can say the relation between the every part, because there is maybe a assembly of nut and bolt, there may be assembly of some kind of links. Okay, so once you will observe the movement of every part, you will understand where is there is a having from where we can able to separate this part. Okay, So functionality is important. So how the function, if you imagine that if the part is moving one part, then how other part is moving, so that you will understand that where you can able to dismantle this part, because at the end we are going to draw a detail view. So for drawing a detail view, we require to make a separate of every parts. Okay, when we are going to separate of every parts, that time it is required to first of all understand the movements. So once you understand the movements, then it is very easy to locate every part separately. Okay, so friends, this is a very much important thing here. We require to locate every part. Okay, because friends, we require to draw every part details. Okay, detail drawing means what? Whatever, how many number of components are included into your assembly drawing. There may be 4 number, there may be 5 number, it may be 6 number. Okay, so every part, once you locate that part, we require to separate out, and every part we are going to draw separately. So this is a detail drawing. So third step you require to follow: visualize the size and shape of the individual component. Okay, once you have locate every component, then visualize the size and shape of individual component. So what is the size of this component? What is the shape of this component? If I am going to draw this part separately, what is the size, overall size? Okay, because in assembly drawing maybe we have given some overall dimension. Okay, so here we require to consider this part as a separate one, and when we are going to consider this part as a separate one, here we are going to visualize what is the overall dimension, what is the length of this component, what is the breadth of this component, what is maybe a depth of this component, if we want to draw a side view. Okay, so here your visualization power is very much important here. Okay, then shape, whether round shape is there, whether square shape is there, or whether rectangle shape is there. Okay, like this we require to visualize the shape, because friends, whatever maybe a 3D view is given, or maybe in your exam they have given a 2D view, it may be only lines. Okay, so that's why if there is a 2D view in your exam, we require to visualize how the parts will look, because sometimes if there is a round, if there is a circular part is also, when we are going on a paper, we are drawing a rectangle. Okay, because it is a convention to draw, if there is a also like cylinder, also when we are going on a paper, we are drawing actually a rectangle. Okay, so it is very difficult to imagine. So here we require to check some kind of top views. It may be in a front view, it looks like a rectangle, but when you observe in a top view or in a side view, okay, it may be top view also may not be it maybe looks like a rectangle, but if you see in a side view, you will see here a full circle, so that we will understand that this is not actually a rectangle, it is like a cylinder. Okay, so like this imagination power is required here. Okay, the next one is step: as far as possible, choose full scale for the drawing. Small parts and complicated shapes may require the use of enlarged scales, so that their presentation will have a balanced appearance. So friends, here whatever the scale is given, try to use full scale. It means whatever dimension is given, try to show as it is on your drawing, so that it is very easy to show your component easily. But sometimes what will happen, friends, whatever the parts there is located like nut bolts, it may be very small parts. If parts are very small, it is very difficult to show on a paper, and someone who is going to observe or who is going to study your drawing, he is also getting some kind of ambiguity to imagine the small parts. So instead of drawing small parts, choose some suitable scale. If you choose some suitable scale, it is very easy for you to understand this thing and enlarge this view. Okay, so whatever the complicated views or some small parts, we can select some kind of suitable whatever scales, and we are going to enlarge this one. Okay, so that we are going to draw a big view, and below that we require to mention that what kind of scale we have selected, whether we have double or whether we have triple, so that whatever who is going to study, he can also understand that actual part is small, but what you have drawn, it is a big by using some scale. Okay, then next step, select the minimum number of views required for describing each part completely. The view from the front selected must provide maximum information of the part. So here, what we require to do, so whatever the number of views, always select minimum number of views, because on a drawing paper we require to draw number of components. Then for every part, if you are using some front view, top view, side view, for every part, what will happen, your drawing sheet will become a large one. Okay, so that's why unless and until required side view, you can be minimize your views. Okay, so that if required more views, then and then add. So always try to use very less number of views, so that there will not be any kind of ambiguity. Okay, because in detailed drawing there may be a number of components. So if you draw with minimum views, every components can be able to accommodate in a same sheet. Okay, so this is the main important thing. And in your most of the thing in front view, try to use number of as good as use more number of detail about the detail dimensions, and mention the detail about component, so that anyone can understand. The next thing we require to follow, the under mentioned sequence may be followed for preparing different views of each part. So that whatever the sequence given in a part list, try to follow this sequence. Then draw the main center line and mark the outline block using the overall dimension of the views. So here, whenever we are going to start to draw all the views, try to draw a main center line first of all, then mark the outline blocks. So whatever front view, top view, side view are drawing, first of all make the outline blocks. So whatever we have imagined or we have seen in our assembly drawing, what is the size of your that part, length, width, first of all try to mark that one by using some outline blocks. Then draw the main circles and arcs of the circle. So try to first of all draw a circle, so that it is very easy to that transfer into other views. So draw the main circles and arcs of the circle first of all, then draw the main outlines and add all the internal features. Then try to add the main outline features, whatever things are given inside your component, and internal features, how it looks, try to draw. Then cross hatch the sectional views. Then if you have drawn some kind of sectional views, if you want to show some kind of hidden whatever shown, then try to use hatching lines if you are going to show a sectional view. Then draw the dimension line and add dimension and notes. So use some dimension lines on your drawing and some kind of notes there. Then check the dimensions of the meeting parts. So whatever meeting part is there in assembly, check the dimension and try to use that dimension into your detailed drawing, and prepare the part list. So at the end, it is important whatever you have drawn in a detail, make a part list. So friends, like this, you require to follow the steps if you want to draw a detailed drawing from assembly drawing. So friends, in today's lecture we have learned about how to draw a detailed drawing from when you have given a assembly drawing. So if you follow this process, then it is very easy for you to trace the detailed drawings and draw the detailed drawings. So I hope friends you have understood about whatever we have learned in today's lecture, and I am very thankful for you to listening my lecture very carefully, and I hope you will again visit my channel for getting you such kind of knowledgeable videos. Okay, so once again, thank you very much.